This is page 2 of the Mod 1 Learning Target Review. All right, so picking up on number 17, the learning target is I can generate the terms of a sequence when given an equation for that sequence that's written explicitly or recursively. All right, so this is number 17. This is an explicit equation. I want the first 5 consecutive terms starting with f of 1. So if I start with f of 1, that means that I have 2 times 3 to the 1 minus 1. Now we know that 1 minus 1 is equal to 0. 3 to the 0 power is 1, and 1 times 2 is 2. And that makes sense because in an explicit function, that number right there should be your starting term. And then, so I can continue and I can say, all right, well, now I want to find the second term, f of 2. So I'm going to go 2 times 3 to the 2 minus 1 power. Now 2 minus 1, that's 1. 3 to the first power is 3 times 2 is 6. Now I can continue that, or using my explicit function, this means I start with 2 and I'm going to keep multiplying by 3. So 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 172. 18, this is an explicit function and it happens to be arithmetic. I know that because it is linear. So I'm going to start with my first term, which is f of 1. And f of 1 is 3 times 1, which is 3. F of 2 is 3 times 2, which is 6. F of 3 is 3 times 3, which is 9. So what this really means is I am just consistently adding 3 every time. So I know my next term will be 12 and then 15. Number 19, I am now given a recursive function, which means recursive, we always get told what our first term is. My first term is 8. And then this is saying my previous term, I'm going to add 5 to it. So if 8 is the previous term, then the next term, if I add 5, is going to be 13. Add 5, 18. Add 5, 23. Add 5, 28. Number 20, also recursive. First term is 12. And this is saying I want to take half of the previous term. So to get to the next term, half of the previous term. My previous term is 12. Half of that is 6. Half of 6 is 3. Half of 3 is 1.5. Half of 1.5 is 0.75. So I just keep taking half. All right. Problem number 21. I'm being told it's arithmetic. So I know that between every single term, there is some common difference. So my strategy here is to look at the last term and the first term. And then subtract. So I'm going from negative 10 minus negative 2. And that's going to equal negative 8. So to go from here to here, I want negative 8. And I did that with 4 common differences. So I'm going to divide negative 8 by 4. That's going to give me negative 2. So my common difference is negative 2. So I'm going to add negative 2 or subtract 2 every time. So I'm going to go negative 4, negative 6, negative 8, negative 10. Problem number 22. Now I'm being told it's geometric, which means I'm either multiplying or dividing. Now I'm seeing that I'm going from 3 to 81, so that leads me to think that I am going to multiply every term by some common ratio. So I'm going to start by taking 81 and dividing by 3. 81 divided by 3. That's going to give me 27. That means from 3 to 81, I have to somehow get to 27 by multiplying by this common ratio. And I have to do that 3 times. So now I'm going to think in my head, what times itself 3 times is equal to 27? And I know that that is 3. So my common ratio is 3, so I'm going to keep multiplying by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, which is awesome. That means we did it right. And 81 times 3 is 243. Last problem on this page, it says, which of these tables could fit this recursive rule? So let's look at this recursive rule. It's saying that the previous term is always being multiplied by 2. So if n is the term, the value comes from the function. So we want to look at this column. Is the previous term being multiplied by 2? I'm going to go with yes. Is the previous term being multiplied by 2? I'm going to go with no. It's adding by 2. C has a lot of 2's in it, but are we multiplying by 2? No. D, are we multiplying by 2? I'm going to go with yes. So the answer would be A and D.